All right. Cool.
Okay. I'm in my quiz. Are you guys in your quiz?
Yeah.
Yes.
Okay, cool.
True linear regression equation is okay. What are the null and alternative hypotheses for beta 1?
So it's the third one? Yeah?
Yeah.
Yeah.
Okay.
Residual. I've got the third one as well.
Yeah.
Yeah, that's what I got.
Plot residual supports using linear regression when see, I'm mixing this up with the 5 requirement thing that they showed that was in this section, I think. So I think I'm looking for something from there.
That's wrong.
I think I just, that's where I was looking as well. Okay, let's see.
How to check residual plot. I'm looking at this chart. It says requirement summary. It says that there's no pattern in the residuals. But that's not one of the choices.
Let's see.
Would it matter if it's positive or negative?
No, because it's giving like the opposite of it. Because section 3.5, that has like a chart of observations that you can look at, and one of them is saying that you should not have a megaphone shape, that there should be no pattern in the residuals. So I'm wondering if this is like a process of elimination thing.
So I think it might be the first, well, I don't know if it matters if it's normally, I don't know. Sorry. I had a thought going, but I'm pretty sure it's not correct. So I'm going to keep reading.
Well, that is one of the requirements but that's for the error term.
Yeah, let's see. Yeah, if linear, I think I'm seeing what you were saying before. If linear regression is appropriate, then the residual plot will show no patterns.
Yeah.
And will consist of random scatter.
Yeah. So that's not the choice.
And then if there's a pattern, it suggests that linear regression is not appropriate. So
it's not the first one and it's not the third one.
Or the last, because
it's not the first one. So it's the
Yeah.
second one. So it's all of them are positive.
Can it be normally distributed but still not have a shape? Probably not.
Can it be normally
I'm
distributed? What?
thinking it's one of the top two.
Yeah, I'm not sure.
Let's guess that they're all positive, and then we will see if we get that.
All right, sounds good.
No.
Normally, we've been doing really well, like flying through these quizzes, so I guess we should stumble sometimes.
True. Okay. Math self-efficacy. I finally figured out how to do this with Excel.
It's opening.
Okay.
Sorry, mine's still loading.
Yeah, I'm just copying my stuff over from SPSS to Excel.
I'm doing mine all through SPSS, so I hope it works.
Yeah.
Yeah.
Apparently I haven't had good luck with Excel.
Okay. Okay. Sorry, I have to. I'm finding the instructions and I'm making it small so I can look at it while I'm on it. SPSS.
Oh no, I do the same thing. That's why you're good. Yeah, that's all lined up, right? Minimize that.
So then we have to create a scatter plot, right?
Mm-hmm. Yeah.
Okay.
Wait, are we making a scatter plot or are we trying to find the? Oh,
Yeah,
It says compute the residuals.
okay,
so that's
you're
the
right.
step 2,
Okay,
residual plot.
okay. Okay.
Okay.
All right. So I'm getting the first one, mine.
You're getting what?
The first one between -40 and 25.
So I'm just making sure I understand what qualifies as a linear pattern. If you just see a trend, like an upward line, like that all the points are moving in a direction, even if it's a big chunk, is that still considered linear? Or do they have to be close together, forming a line?
I think that if it's a linear pattern, you can draw a line on the data
Mm-hmm.
and it should hit most of the data points. I think.
Okay.
Think
Gotcha.
so.
But I see what you're saying. Like what I'm
Yeah,
seeing
'cause-
is they're in
'cause
a
mine-
line, but they're kind
Mine
of
makes a scatter plot
wide.
and it shows it going up like this, but it's a wide chunk.
Yeah, that's mine as well.
Yeah.
I know. How big can this line be? Can it be super big? Because then it works.
Yeah, I don't know. Like what? The residuals aren't all negative. So yeah, I think it's the first one. I think I'm gonna go with Trevor.
Sounds good.
Based on
where's Trevor?
Did he disappear on us?
Yeah, sorry, I
Yeah,
always
yeah.
minimize. Yeah, I always
Started
minimize
to
it.
say something and then he got cut off, but I don't have my like the screen up.
Yeah, that's what I do. I minimize it, and then I hear you guys, and I know who's who, obviously. But
Yeah.
yeah,
I
I
mean,
heard that, and I'm all wait, so I opened it and must have kicked him off.
Yep.
Oh, there he is. All right. Hey, you're back.
There we go.
Okay. Let's
All
see.
right. Next question. Based on the QQ plot, what can you say about these residuals?
Can we call them fairly normal? If it's like they're in a linear formation but they're wide, I don't know.
Yeah, I mean, I wouldn't say they're clearly not normal, and I wouldn't really call them right skewed either. I would say fairly normal. What do you think, Trevor?
Well, did you guys just run the QQ plot?
I ran the scatter plot.
See, yeah,
Maybe I
Yeah.
ran one.
I ran the scatter plot for the last one, but for this one with the QQ, I think then we have to create it, a QQ plot.
Oh, you're probably based on the QQ plot. Okay, I will make one of those. Sorry.
Well, just when you said fairly normal, I thought scattered, but
You're like, I'm not seeing that at all. Okay. Sorry, I will create that and look at it.
yeah, I think you guys were right anyways.
Let's see. I must be having some sort of brain problem. I'm like, how do I create a QQ plot again?
I'm trying to think of how to do it in Excel.
Yeah.
Because it's just a residual plot. Yeah, because it tells you to just make a scatter plot here. Unless it's, hold on, let me scroll down more to make sure there's not a separate set of instructions for a QQ plot. Yeah, I don't think there are.
So I've created a QQ plot through SPSS, and it's a straight line.
So would that be the fairly normal?
Yeah.
Okay.
Still PSS.
Are you in SPSS, Megan?
Yeah.
And then did you figure out how to do the QQ plot?
No, that's what I asked you. I made a scatter plot and I'm looking at it, but I don't remember how to do a QQ plot.
So that would be through analyze, descriptive statistics, and then
okay. I kept looking under graphs. Okay, thank you. All right. Okay, and yes, okay, fairly normal. Thank you, Trevor. I couldn't remember.
If you saw the notes that I have to take, you would understand why I know how to get there.
I'm like, how come I can't remember how to do this? I feel like every time I read a new lesson, it's like all the old information just it's still there in the back filing cabinet of my mind, but I don't ever really think about it. So okay.
So let's take a look. which of the 5? Okay, which of the 5 assumptions are satisfied?
Okay.
Do we know how the data is obtained?
Oh, sorry.
Hi, Mommy.
1 sec.
Hi, Mommy.
Hi. Just 1 second. Okay? Okay, sorry. It's just my 4-year-old.
No, good.
Okay. Which of the 5
So I'm
assumptions?
looking at this and
Yeah.
going back to even the section. Okay, to illustrate the things here, I'm trying to make sure that. So we check to see if it was normally distributed.
So okay.
Um,
So
And I'm using that chart on the 3.5.
that's what I'm
Yeah.
using as well. So the linear relation. So the first one I believe is true. Sorry, I don't know if you've already talked about this stuff.
No.
So there is a linear relationship because it is a hot dog shape on the scatter plot. Let's see. Then
Points in the QQ plot are close to the line.
No megaphone shape in the residuals.
right.
It wasn't a megaphone shape.
No.
So that would be 1.
Yep.
Residuals are normally distributed.
So would the second one, the variance of the error term is constant for all values of x, is that the same as normal error term?
Say that again.
So I'm looking at the chart and I'm looking at the options for the question. And one of the options is the variance of the error term is a constant for all values of x. Oh, I'm pretty sure I just figured out which one that was. I think that's number 4. X's are known constants. Sorry, I'm just trying to understand. I'm trying to understand what they mean.
No, actually, I think they have them. They have the 5 points in order, the same way they're listed in the textbook.
Are they? Okay.
Yeah, so they haven't scrambled them or anything.
Okay. Because we were saying points, you were just saying, Brian, points in the QQ plot are close to the line, which is true. So I believe the second one would also be true.
Then I have all 5.
Do you? Okay.
Yeah. I mean, you guys can look at, because we talked about the megaphone, how that's not there. X's should be measured precisely and accurately. They go out far enough. I don't know, from a decimal point standpoint, it doesn't look like there's much rounding involved. That's all I really have to go off of.
Right.
And then knowing the value of one of your y's tells you nothing about any other points, which is also true.
Which is true. Okay. I believe you are correct.
So I'm getting the second, the third one. The first one doesn't even make sense to me, but then the last 2 on the plot or on the chart, it says that those ones can't be checked. So I don't think it says the x values are measured without error, but I think that means that they can't be measured, but maybe I'm wrong.
I'm not sure how to check that because, hold on, let me scroll further down in the lesson because I think that that's when they start to address it more on how to check the individual observations, I think. But
You're
yeah, but
looking
I'm not
at,
even seeing that.
so are you looking at the results in the SPSS, Trevor, under like the model description?
No, I was just looking at the 3.5 chart that says those last two cannot be checked directly, cannot be checked.
Oh, I see what you're saying. Okay.
Yeah.
So I'm just assuming that those can't be measured, but that's just Brian. If you feel confident in that, I say we go with it.
Well, honestly, it's only because I read through this section and there isn't, I guess I didn't, because I just kind of looked over the chart really quickly. I assumed that they were going to go through each of the 5 variables individually because I feel like that's what they said they were going to do. And I didn't see much on that, so I didn't really know how to test it. So if it's one of those that can't be measured directly, it's one of those, if we don't know how to measure it, we won't. We'll go leaving them blank for now, and if it doesn't work, we'll check them off and see if that changes anything.
Okay. Sounds good.
Estimate for the slope.
Okay.
Okay. I have 0.042. But then again, these charts have been getting so confusing, I never know if I'm looking at the right number.
I
I think my answer is 0.042 from what I see.
Point B1, which would be not the constant. I'm getting, the one I see is 12.695
see.
under. Where are you getting yours? But I guess we're not on SPSS.
Yeah, so mine, I put in the variables. I put in the confidence level. Like the confidence level and all those things don't really affect it, but just putting in the explanatory variable and the response variable, it gives me the numbers here. So I can actually just do this.
Sorry, quick question. The
Yep.
score is the dependent variable, and then the confidence rating is the independent. Is that right?
Say that again.
So for the 2 variables that we're using,
Yeah.
Score is dependent and confidence rating is independent.
So constant would be the BO or the Y, and then the confidence rating would be the slope or the B1. And then I'm assuming that B is the label for BO and B1, for the slope and the Y.
Okay. Okay,
But
never mind.
it's interesting. Did you get that same number, Megan?
So I just got it now, and I'm looking for it now. I was just running SPSS, and that's what I was trying to figure out if I was running it right or not. And
Yeah,
I
and
think I did. I'm still
If you
confused by
ran a
that.
scatter plot, it should be there.
Oh, okay. Oh, well then I was running something totally unnecessary. Okay. Let me look at that. Click on statistics. I was actually following, I was doing the SPSS instructions under section 5. So it's for the slope and the y-intercept, and I was running that, and that's what I was trying to, anyway, that's what I was looking at. But
Okay.
let me look at my charts. Oh, click on, oh, I didn't do that. Sorry. One more second. I mean, I don't know if this is how you found it. This is just, let's see. Intervals, 95%. Okay, okay. 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 And the coefficients output. Okay.
Okay.
So I ran it through SPSS, and maybe I think we're just trying to find the slope. I'm getting confused. What is B1 or the estimated slope?
B1 is the
Okay.
slope. Yep, that's what we're looking for.
Okay. Sorry.
All right, good.
I get really confused by all of these. Okay, so I think this is, anyway, so I got 18.690.
18.690. And then underneath that, did you get 12.695?
Yeah.
So the slope would be the latter.
The second one, that's what I was trying to figure out. I was trying to figure out which numbers were which. That's why because it says, oh, the slope is this, but it gives you two numbers. And so I was like, oh, I don't know what that means.
Yeah,
Yeah.
that's probably the hardest part for me. Terms. I'm like, oh no. But
Okay.
what do you think?
But those
Brian?
Well, I'm just confused because I'm following the instructions that it's giving me to do for Excel, just because I'm seeing if the answers are matching. It's like, go click on that. Maybe it's possible I just have these backwards. Because Megan, you asked the same question a little while ago, and I think let me just make sure I have it right. Also, pull this up. So our explanatory, like, which ones are X variable and which ones are Y variable? Which ones are explanatory and which ones are response? I think I'm just going to ask that just to make sure that I'm looking at this correctly.
Okay, so I get confused with the letters. I'm just checking really quick. X is the dependent, right?
I believe so.
Okay. I'm pretty sure that's right. So when I ran it through
No,
SPSS,
X
no?
is the independent, Y is dependent.
Okay. Sorry. Okay. How did I do it? I'll tell you in a moment. So I did the score was Y, and
Okay.
the confidence rating was X.
Okay, yeah. So that's what it was. I just put mine, I had them flipped, which was
Okay.
the only issue there.
Okay. I get those confused, so I wasn't sure. That was the question I was asking like a while ago, but I didn't really understand I didn't know if that was right or not. But since Trevor got the same answer, I'm gonna assume that that's correct.
Yeah, I have 12.695 now that I've switched them.
Okay.
Yeah.
All right. Okay. So 12.695. Now construct it. Input your answers for the lower bound and the upper bound.
Okay.
Okay. I think Let's see.
So just to the right of that, you see 10.674 for the lower, and then 14.715 for the upper.
I have those same ones.
All right.
Okay. So based on those values, what outcome would we get? Decision we make regarding that.
Okay. If it's 0.05, what you make regarding BV1? Fetch this.
Oh, so now we use p-value again, which I think is found under the SIG, SIG, significance.
Using the T, is that what you guys are using? I didn't hear what you said.
I was thinking it's the significance, the SIG.
Yeah.
Mhm.
Yeah, and I have 0 for that.
Yeah.
Okay.
So that narrows it down to rejecting reject the null hypothesis because the T is equal.
That's not the
Or-
value of T. The value that they have in that answer
True.
isn't the correct one.
Okay.
So I'm gonna say
So I just,
say it's the third one.
yeah,
Yeah.
I would say so. Okay. For a hypothesis test for B1, if you reject the null, what does it mean? If you reject the null, so there is insufficient, sorry, I'm just talking out loud. I'm not
No,
reading
you're
it.
good.
Insufficient that if we reject the null, that means we have sufficient evidence for the alternative. So sufficient
That it
that
is
the
not
slope
0.
is not 0. Okay. So the last one.
Okay.
Okay.
Is that right?
Mm-hmm.
Yeah,
Okay.
I think so.
Use the data for this. Woo! Another data set. Yay! I feel like I'm very, very slow tonight on this, so I'm sorry if I'm holding you guys back from, going faster.
Oh no, you're good.
You're doing great.
Okay. Okay. So, which variable is the dependent? The body length.
Didn't we talk about this in a previous lesson?
Yeah. I think it was the same data set.
Yeah.
Because I remember talking
Yeah.
about those crocodiles.
Determine margin of error.
Okay.
All right, I need to write this down. We just talked about this, but I didn't write it down. X and Y, which one is dependent? Which one?
Okay.
The
So
explanatory is the okay. Yeah.
So X is independent. And Y is dependent. And I don't know how to remember that other than Trevor just said it, so I better write it down too.
Okay.
I thought was the other.
Because the X always comes first. The independent comes first. Headlong is your independent.
Yes.
Body is dependent. Is
Okay. X always listed first.
Okay.
All right.
All right. All right, for B1, we're looking for the error.
Now, if it just wants, oh yeah, okay, confidence interval.
Yeah, so if we're doing the margin of error, we find the difference between the lower and the upper bound, and then we divide that by 2. Is that right?
Say that one more time.
So we take the lower and the upper bound, and we divide the 2. Or I mean, we find the difference between the 2, so subtract one from the other, and then divide by 2.
Yep, subtract the lower bound from the upper bound, and then
Okay.
divide that answer by 2, and that's your margin of error.
Oh yeah, forgot about that shortcut.
Yeah. I don't know. I feel like SPSS is a better, like it helps you understand the material more, and it's good for learning it. But I feel kind of, I don't know. I just put in the data, and I already have all those answers.
Oh, lucky.
It just kind of spits them out. Like,
Oh, maybe I should learn how to use Excel. I'm like, wait, how do I do this again? I can't remember
you just have to.
anything.
All you got to do is you just copy it and paste it, and that's it.
Well, I'll have to learn how to use that too. Okay, so then is the margin of error 0.4425 or 0.443?
Yeah, 0.443.
Is that what you got, Brian?
No. That is backwards again. This is the worst.
Okay.
Because I have 0.215.
Oh. Huh.
Because
Okay.
the explanatory variable is because X is your independent and Y is your dependent.
Mm-hmm.
Yeah, so that's what I put in there. So I have the data put in there correctly. I have a 95% confidence interval.
Okay.
And let me make sure. I'll go back into the lesson to make sure I'm pulling the number from the right place. But
Well, and I just
or I can do it.
Well,
Yeah.
maybe it's me. I took the lower and the upper bound from the independent variable. Do I need to take it from the dependent? I don't know.
Well, no, because the slope should just be calculated. Like it's the same thing that you guys just did to get the upper and lower bound
Okay.
for your slope, like you just did for the previous problem. So
Oh, okay.
that's how you'd get it.
Okay. And then
Because when I do what you guys are talking about, when I subtract
Mhm.
and divide by 2, I get 0.4425 also. So maybe it is that you guys are right, but here there's just a thing that says standard error right next to the slope, and that number is 0.215.
Okay.
So that's where I got that number, but I think my lower and upper bounds are exactly the same as yours.
Okay.
I just don't know if
That's-
margin of error is calculated differently in this section or not.
And maybe
Now-
it is, maybe it I don't know. Let's see.
Did
I don't
you
even
say-
remember. Oh, go ahead.
Well, I just noticed, Brian, you said now when you put it in a different way, it gave you 0.442. Is that right?
Oh no. When I just did what you guys did, take the upper, subtract the lower, and divide by 2, I get the same answer you guys get. The only thing that's throwing me off here is where's the thing? There's a part on this Excel spreadsheet here that says standard error right here. And I just don't know what that is. I thought that was my margin of error, so I wrote that down. But my upper and lower bounds
I
are the
see.
same as yours. So if that's what we're doing, that would be the margin of error. So I think I just got mixed up in looking at the wrong number.
Okay.
So yeah, I'd say it's
Yeah.
still 442. Same thing you guys were saying.
Okay.
Now I'm curious because I remember I used to do this by taking I would take the number that we need, so the slope, minus the lower and minus the upper, and I would get the exact same number. And then Brian was like, you can do that by just finding the difference between the upper and the lower, and then dividing by 2.
Mhm.
Yeah, because the
Uh,
lower and upper are it's just the same distance from the mean. Like it's just, yeah.
So Trevor, you took the slope and you subtracted the lower and the upper bound. Is that how you were saying you did it? Oh, kick Trevor off again.
What the heck?
I noticed a second ago when you were doing the screen share, his screen had frozen and it was just his hand was on his chin and it wasn't moving.
Well,
But
he
he was
just said
talking.
something, so I don't know.
Yeah,
I gotta
I
stop
know.
doing the screen share thing. Maybe that's just wrecking his computer.
I don't know. Could be. I think that's what he said. I'm gonna look at that and see if that gives us the same answer. Because if it is, then
Yeah.
we should just go with that. 0
Okay.
minus.
Hello?
Hey.
Hey.
Oh, sorry.
No, you're good. Trevor, you gave some instructions on how you used to calculate the margin of error, and Meg just wanted to make sure she heard you right.
Yeah.
So basically, I tried it the old way that I used to do. Then I tried it Brian's way, and Brian's way shows that it would be let me go back here. 0.443 if I round it up, but
Yeah.
Okay.
the way shows 0.442.
Oh. So the way that you had said, which was to take the slope and then subtract the confidence intervals, is that how you did it?
How many decimal places do your upper and lower bounds go on SPSS?
If you double click on them, it takes it out to like 8.
Okay, because mine takes it out to 3, and when I subtracted, I got 0.4425. So yeah, I got 0.443 if I round up. Just doing the subtract and divide by 2.
Okay.
But so 0.443, is that what we're going with?
Yeah, let's go with that.
Yeah.
Okay.
Okay. Awesome. So that's what I got. So hopefully that's correct. I never
Okay.
really know if I'm doing things right in this class, so we'll just go with it.
Okay. And then based on your lower bound and your upper bound for the last 2 problems, what can you say about the slope? 95% confident that the confidence interval will contain the true value of the slope?
Yeah.
Yeah, I would say so.
Okay. All right. I'll go ahead and submit, and I'll see what happens. Because I know we had some up in the air ones throughout. Okay. Let's see what we got here. Oh, we got one wrong. Where is it?
Hey, only one. That's good.
Yeah. Which one is? What? It's question 5.
What's question 5? Oh, the plot of residual supports using linear regression 1. This was with the shapes and stuff. We didn't really know what to put.
Yeah, we ended up putting all residuals are positive, or at least that's what I
Okay.
put.
So maybe if they look normally distributed, because
Hold
That's
on.
my
The
best
plot
guess.
of residuals. Where's the? Because I think it is in that chart. I think now that I actually understand that chart more, I'm
Yeah,
pretty sure the answer is in
I
that
know.
chart.
Yeah, let's look at the
The
chart.
residual plot. What you hope to see is no patterns.
Yeah, the residual plot, no patterns.
Is a megaphone shape no pattern? I'm so confused right now.
Yeah, I think that one's a pattern of being small
Yeah.
and large.
Yeah.
Well, and later, yeah, and then it says no megaphone shape in the residuals. It's what we
Yeah,
hope.
this
question
is
is
the weirdest question.
It's very confusing.
It's got to be the top one.
Okay,
All right, we're gonna
All
go with that. All right, someone submitted again then.
I
Wait.
marked the. Mark the first one. Wait, are you submitting it, Trevor?
Well, I just wanted to ask, was number 8, was it all 5?
No, it was just the top 3.
Top 3, okay. That's what I was thinking.
Oh,
Yeah.
okay. I think I had marked all 5, so I will change that.
Yeah.
Okay. I've
Okay.
updated number 8 and the one we just fixed. Let me submit it, and then I'll look at it. Boom, we did it.
Okay. Let me make sure I'm looking at this right. Question 4 is the difference there. I have them both pulled up, so I should be able to get through this okay. But yeah, we're good. We got 100. Trevor, you have the part of the project this week. I don't
Actually,
know.
I have it.
Oh, you have it. Okay.
You do?
Yeah.
Oh, okay.
I believe I do. Maybe I don't. I should
I
look
just
at that.
remember looking at the list, like the first sheet we made, and I thought it was Trevor, but maybe I just forgot. But
Yeah, I'll look at that.
I guess
should probably-
I guess I don't know what it means to describe the data. Apparently, describing the data does not mean running the test.
Really?
Yeah, they said, yeah, you shouldn't have put information from the square test in your describe the data thing. I was
Well, it
like,
looks
then
pretty
Oh.
good.
what was I supposed to do for 3 paragraphs? Like,
I was gonna
these are the
say,
numbers.
what
Look
do
at
you
all
talk
these
about?
numbers.
Oh, that's weird.
So these graphs here of color frequency, she was saying you didn't need to do that?
No, the graphs of color frequency were fine, but I brought towards the end, I put in the variables that I got from running the test.
I
And they
see.
were like, you're not supposed to run the test in this step. I'm like, what do you do? Like, isn't that what would best
Like-
describe the data is running the test? So you learn.
I would think. Or you just talk about the colors of M&Ms for 3 paragraphs. I
Like,
don't know.
I didn't know. I'm like, well, this number is different from this number, so there's a chance that our hypothesis might be wrong. I don't know what she was expecting us to write. But
I don't know.
yeah,
And you're right, there wasn't a sample of that one. Like
Yeah.
there was an example, but it was for a different test, so it was hard to
exactly.
say.
So I wasn't really sure how to do that one. So we got an 80 on that portion.
It's all right.
So
Close enough.
yeah, close
Looked great.
enough. So
It's like it's like exam scores there. That's fine.
yeah,
Just-
seriously, there's just days where we're just like, yeah, whatever, don't care anymore.
Yeah. Yeah. So I do this next. I am in charge of this next section, and she does have 2 samples. One's categorical and one's the other one. So I'm just gonna basically do what she did in her sample, almost like to a T. I'm just gonna kind of.
And she was really particular. She's like, it has to have this thing is worth this many points, this thing is worth
Yeah.
this many points.
So and in fact, I'm gonna. So I will work on that tomorrow morning, and I'll send it to you guys. But I am gonna send it to her. She said if we send it before Thursday, she'll look at it. So I'm gonna do that. Since there's so many parts, I don't want to miss anything, and then we miss points, So
Yeah, I get you. Just gotta make sure I'm copying these numbers right because I feel like I'm missing something. All right, well then if that's all we need there, then yeah, then we'll see each other on Thursday. Thursday's the review for the exam, right?
I think so.
I would think so.
Yeah.
She said she's gonna do the review like on Friday. I'm sure she'll send an email, like her
All right.
live one.
Cool, yeah.
Um,
So I think lesson 24, I think this was our last lesson with new material today. So,
Oh.
yeah. I think everything
Good thing
else
it was
is
so
just
confusing.
perfect. I know. We have to have one of those every time, so that works.
Yeah. I do have a question, and if the answer is that you guys have other conflicting things, that's fine. I know we switched the date last week already. So is it possible that we can meet tomorrow night instead of Thursday night?
I don't see why not.
Are you guys free? I can do any time. It's just Thursday I have a rehearsal for a Christmas program that's going on this weekend. And that goes
I
from like,
can.
okay.
Yeah, that should work fine.
Okay. Awesome. You guys are the best. Okay, so 8 o'clock, or should we do 8:30? Does that work better for you guys? I honestly, it doesn't make a difference to me. And actually, I don't know if we'll even be meeting again.
I'm fine with
after-
either.
Okay.
Yeah, so if we want to do 8, if we want to do 8:30,
What
I'm
works
good with
better for
either.
you, Trevor?
Probably 8:30 if
Okay.
it's tomorrow night.
Yeah, that's fine.
Sure.
I can do that.
Sure. We'll do 8:30 then.
Awesome.
Cool. Thank you. Thank you for switching it. I appreciate it.
Yeah.
No problem.
All right, great. Then you guys take care. See you guys
Yeah.
tomorrow.
See you tomorrow. Bye.
You guys, thanks.